This is a continuation of our discussions around risk quantification. We're going to take a quick look at sensitivity analysis, then we're going to spend a bit of time on expected monetary value and decision trees, and then we'll continue with having a discussion around risk response planning as well as risk monitoring. So, what is sensitivity analysis? It's one of the tools that is available to us for quantitative analysis of risks. And essentially what this means is that we take a look at one risk and break it apart into various elements and various parameters that affect that particular risk. And then we start to change the values for those parameters one by one. So one at a time perspective, we will be changing those parameters to see what the impact of the risk is going to be on the overall project, so the triple constraints in the project. The next tool that we have is expected monetary value. This tool looks into finding an average of the outcome of an event. So let's go over an example which will help us understand this better. So in our example here, a dairy farmer estimates for the next year the farm's cows will produce about 25,000 gallons of milk. Because of variation in the market price of milk and cost of feeding the cows, the profit per gallon may vary with the probabilities given in the table below. Estimate the profit on the 25,000 gallons. So essentially, we have a project, and as part of our project, we are producing and managing the production of the milk, and we want to find out what the expected gain is going to be, some sort of an estimation of the gain. Now, we have various scenarios here. In one scenario, the probability of 30%, but the gain per gallon in this case is $1.10. Then there is another case, another scenario where the probability is 38%. So there's probability 38% that this scenario will happen. And under this scenario, the gain per gallon is going to be 90 cents, and so on. And in the last one, we have the probability of 2% that we will actually be losing 10 cents on a gallon. And also we have this scenario here that there is 4% probability that there's going to be no gain at all. So what I'm going to do is I'm just going to move to Excel for a second where I have put these numbers for now. And so I can do the calculations a little bit quicker. So what I'm going to do is I'm going to find the product of probability and gain per gallon. So probability times gain per gallon. And this is going to be the expected gain per each scenario, per each case. And this is going to be the probability times the gain per gallon. And let's do this. So for each scenario, now I have an expected gain. So for instance, in this case, when there's 38% probability of gaining 90 cents, this translates into 34 cents gain. But that's not the total gain. This is not what we're going to see. The total estimated or the total expected, and in our case, estimated gain per gallon, it's going to be the sum total of all these numbers. So this is very important to understand that each scenario on its own mean nothing really to us. But in our case here, we have an expected gain of 83 cents per gallon. So as you can see, this is really a weighted average of all these gains, like 30%, 38%, 20%, 6%, 4%, and 2%. We have applied each one of them to the provided gains per gallon, and then we add them up to get the weighted average of all these gains, which is going to be the estimated gain per gallon, which is 8. We can take that and turn it into a decision tree. So what is a decision tree? A decision tree is a tool for us to compare various cases and be able to make a decision. Now, we can use a decision tree to do other things and not make a decision at all and just come up with different scenarios posted as well. So let's take a look at this particular example here. In this case, it says you have the choice to make or buy widgets for resale. If you make the widgets yourself, you must purchase a new machine for $35,000. If demand is good, which is expected 70% of the time, an $80,000 profit will occur on the sale of the widgets. With poor market conditions, $30,000 in profits will occur, not including the cost of the machine. If we subcontract out the work, our contract admin cost will be $5,000. If the market is good, profits will be $50,000. And if the market is poor, profits will be $15,000. Now let's move on to solving this case. So essentially, this is a make or buy decision. And make or buy decision is a great example for doing decision trees. So I'm going to start by drawing two lines here. And that's the other one. And here I'm going to say make. So this is going to be the make scenario. And then here I'm going to say buy. And this will be the buy scenario. Now, going back to the case, again, it says, if I decide to make, I need to spend $35,000, which is going to be a negative number because it's an investment. So $35,000. So let me write it through here. So $35,000 investment. I need to do that. And is there an investment for buy? So let's take a look at the buy scenario. If we subcontract out the work, so that's the buy scenario, there's going to be $5,000 admin fees. So this is going to be another $5,000. So these are the two investments that we'll have to do. Just because I want to differentiate between the different sections, I'm going to draw a circle here. There's no need to use any specific shapes, but shapes help with organizing our decision tree and making them more readable. So I got my two scenarios of make or buy. So let's focus on the make situation. Make says if demand is good, which is 70% of the time, then $80,000 profit will occur. And let's label them. So demand, so good demand. Versus poor demand. And we already know that this is 70% of the case, so that's 70% of the time. But we don't know what is the probability of having low or poor demand. Of course, if it is 70% for good situation and a good demand, then this is going to be 100 minus 70, which is going to be 30%. And we know that if demand is good, then the profit is going to be $80,000. And if the market conditions are not good, then the profit is going to be $30,000. So there is profit in either case. Then we get to the second scenario, which very much like the first one, has two cases of good and poor market conditions with the same probability levels. So 70% and 30% for poor conditions. And of course here we have $50,000 profit versus 50. So we got $50,000. As we just talked about, expected monetary value is nothing but a weighted average. And what we're dealing with here is an expected monetary value. So very much like the other example we had, we have probabilities and we have different outcome. So what we need is to find the weighted average of these two particular outcomes. So what we're looking for is 80,000 times 70% plus 30,000 times 30%. $65,000. Now, in the second case here, again the same process. 50,000 times 70 or 70% plus 15,000 times 30%, which will give us times 30, that's 4,500 plus 35,000, that's 39,500. 39,500. Now, I shouldn't forget, obviously, that there are initial investments that I have to apply. So these are not profits, these are purely revenue. Expected revenues in each case, expected monetary values for each case. So now we are going to implement and apply the initial investments. So 65,000 minus 35,000, and that's not, that is 35,000, which will give me a profit of $30,000. And this is the final profit and final result from applying, after applying the initial investment. So if I decide to make the widgets, then my profit will be $30,000. Now let's see what the profit would be if we decide to buy the widgets and essentially outsource them. In this case, it's going to be $39,000, 39,500 minus $5,000, which will be 34,500. And as you can see, in the first scenario, the profit is $30,000. In the second scenario, the profit is 34,500. So I am going to mark this as the winner, and this is really what we should do. This is how we should move forward, essentially, because let me just select this one as well, because I want to mark this. And this is really the case that we have to follow, and we should buy instead of make.